This video is on key features of a function. The first thing we're going to talk about of a function is the domain. The domain of a function is all of the input values, which are the x's, that go into a function. The other part of that is the range. The range is all of the output values, which would be the y's, that come out of a function. So the domain is what goes in, the range is what comes out. So if you're thinking about like a vending machine, you can put in money and you get out your soda. So the domain are the x values, what you put into it, and then the range is what you get out of it, the y values. So we also have on functions, we have y-intercept or y-intercepts, depending on how many times the graph crosses it. So the y-intercept is the value of y when x is equal to 0. So another way of looking at that is when the function crosses the y-axis. So on here we have a graph and a table. I'm going to use a highlighter. So I'm going to highlight y-intercepts. Now I want to find where on the graph it crosses the y-axis. This is the y-axis, and the graph crosses that y-axis at this point right there. So I'm looking at my table, I look to see where x is equal to 0, and then my y-axis, my y value is the y-intercept. So this would be the y-intercept, 0, 4. And it's the same point, 0, because I'm not going on the x's. Y is 1, 2, 3, 4. So that would be the y-intercept. The x-intercept or intercepts is very similar. It's just in this case, it's the x values, or just values, when the function, which is y, equals 0. So when y is equal to 0, it's the x values when y equals 0. Or another way, if we're looking at the graph, when the function crosses the x-axis. So I'm going to get a pink highlighter. Going to highlight the word x-intercepts. So on my x-axis, which is the horizontal axis, I see that my function crosses at two different locations, right here and right here. So my function will cross at two different locations, so we have two x-intercepts. So if I look at my table, it's when the y value is 0. So if I look on the y value, I have a 0 here at negative 5, 0, and also on the y value down here at 6, 0. And if I look at my numbers on my graph, so if this is 0, 0, I have negative 1, negative 2, negative 3, negative 4, negative 5 on the x value, and the y value is 0. Negative 5, 0 works. So again, if I go back to 0, 0, the x value of 1, 2, 3, 4, 5, 6, and the y value of 0, I have 6, 0. Those are the x-intercepts, where it crosses the x-axis. The next key feature we're going to talk about is the maximum of a function and the minimum of a function. So the maximum of a function is the highest y value. Maximum means the largest you can have, so the maximum of the function is the highest y value. It will be a coordinate but the value of it comes from the y. So if we're talking about the minimum, minimum is the lowest, so the lowest y value. So we want to find the coordinate of it, and the value of it comes from the y of the coordinate. So if I look at this graph, I want to find the highest y value. So on the graph itself, it goes down, it comes back up, goes down, flattens out, and goes back down again. So just because it starts over here at this dot does not mean that's the highest y value. So what you want to do is when you look at the graph, you want to go to the highest spot on the y, or the largest y value itself, which is up here. That's at that value of 6. So this is the highest y value. We can do the same thing by finding the lowest y value by moving our paper down on the graph. And I want to stop when I get to the lowest spot of the graph, which would be right here, because I can still see a piece of the graph underneath the paper, and that's as much as I see. There's no more graph down here, so this would be the minimum. So we have our maximum up here, and we have our minimum down here. The next thing about features, the key features of a function, the key features of a function is when is it increasing and when is it decreasing. So increasing in value is the interval over which the graph or function increases as the x values increase. So what this means is as you go from left to right, as you're moving from left to right, because that's what x values are increasing by, as you're moving from left to right, when is the graph going up? So when we're talking about decreasing, it's the same information. It's the interval over which the graph/function decreases as the x values increase. So again, both of these, the x values are increasing. The x values are going from left to right, and we want to know when is the graph going up and down as we move from the left to the right. So as we go from this starting point on the left and we move to the right, we follow the graph itself. So as we start from here, my pen would go down, keep going down, and then it comes to a turning point. Then as I continue from this point onward, my pen is going up. I keep going, and then I come to another point, a turning point. Then as I move forward, as long as I keep going right, my pen is now going down. This is decreasing. So if I'm looking at if I highlight this value, this left part from the starting point to this turning point is going down. This is my decreasing. Then, after that turning point, it starts going up. So this is an increasing interval until I get to that turning point. Then from that turning point, it goes down again until it ends and it's no longer moving. So we have 2 intervals of decrease and 1 interval of increase. The interval is from the x value to the x value of the increasing and decreasing. So it is decreasing from -4 until, come to this coordinate, until -1. Then it's increasing from that same -1 until, if I keep going until it stops, this x value is a +3. then it's going to turn again, so it's going to decrease from that same value of positive 3 until it stops at positive 6. So the intervals of which the graph is going up or down as you are reading from left to right, that is increasing and decreasing.